All right, hello everyone. My name is Timothy Lee Grant, and we are back for another Leetcoding video. And so, oops, I forgot to make myself float on top. So let's fix that problem. There we are. Okay, so I am going to go and try to choose one of these topics. Again, we're kind of doing low energy Leetcoding right now. We're not trying to be intense. We're not trying to really go at it. We're just having a good time. We're just seeing what's out there, getting our mind to be able to see a wide array of different types of problems. So, which one should we choose? We did a dynamic programming yesterday, I believe it was, and I think we did a greedy method the day before that. So why not a sorting? Let's try a sorting. And I'm gonna actually make myself a little bit smaller. All right, what's this one? Looks like that one is a medium, so let's not do that. Merge sorted array. Okay, let's try this. Easy. Make myself a little bit brighter. Have to wait for it to load. All right, here we go. Number 88, merge sorted array. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. Okay, so non-decreasing order, what does that mean? It means increasing. Okay, that's it's a little bit of a strange way to say increasing. And two integers, m and n. All right, so we're given m and n, representing the number of elements in nums1 and nums2 respectively. Okay, so that's just the length of nums1 and nums2. I'm not sure exactly why they have to give us m and n, because I think we could just get that for ourselves. But interesting. I'm wondering, is this a red herring, or do I actually need to use this? So some things to keep in mind. Just because a problem says something doesn't mean that we actually have to use it, right? Merge num1 and num2 into a single array sorted in increasing order. All right. Find the sorted array should not be returned by the function, or the final sorted array should not be returned by the function, but instead be stored in nums1. So we're not returning a list of the result. We're just putting in nums1. So we're changing nums1 to add more elements in it. And nums1 will be essentially our answer. To accommodate this, nums1 has the length of m plus n. Yep, so the two lengths, where the m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Hold on, wait, what? Where the first m elements denote the elements that should be merged. Okay, and the last n elements are set to 0 and should be ignored. Oh, okay, so we're given nums1 and it has three essentially placeholder 0 values, and we just ignore those. All right, so the way that I'm thinking about doing this is just having two pointers. So I have a pointer here, and I have a pointer here. I'm going to ask which one is larger. Well, this 2 is larger, right? Okay, so I'm going to move the smaller element. Bam, right here. Then I say, which element is larger? A 2 and 2, so they're equal, so I can insert the list, or I can insert this 2 right here. Okay? noticing actually that that is going to be kind of an inefficient solution because I will need to take all of these numbers before it and scooch it over. That's not a very good solution. Okay. So that's going to be a very long. That would be what? O of n, or wait, this is m. So O of m, and I would do that operation. So I need to go through each of these for one operation here. So if I need to insert this 2, I need to go through all of those elements. So what is the worst case time complexity? It should be m, that'd be times n. I mean, maybe we can try doing that solution, and then if we are able to get it, then what we do later after we solve it, we go to GPT and see if it can think of a more efficient solution. So anyways, how I was kind of planning to do this was I have a pointer here and I have a pointer here. They're equal to each other. So I'm just going to insert the 2 behind it. And the reason it's behind is because let's look at this 3, and that doesn't. So let's pretend that this 2 wasn't here. So it's 1 and 3. Okay. So I have a pointer here and a pointer here. I say which one is smaller? The 1 is. So I'm going to go to the next element, which is 3, because that 2 is no longer there. And my pointer is still here at this 2. I say which one is smaller? Well, it's the 2. So I insert behind, right? And I just want to insert behind. So I'm always asking what's smaller, and then I insert behind. Okay, so let's start coding this up. So pointer 1 is going to be 0. Pointer 2 is going to be 0 as well. It's the 0th element. Okay. So now while pointer 1 how do we want to do that? Well, pointer 1 is less than m? I think so. Because I want to keep going, and then I'm going to keep inserting. But I also want to make sure that here. All of these are like 9, 9, 9, 9, 9, 9. And here we have 2, 5, 6. So which one? Actually, sorry, 1, 1, 1, 1, 1, 1. And this is 2, 5, 6. So I'm going to come here. My pointer is going to be here. Then it's going to move here. Then it's going to move here, 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 here. Wait, no. These are all going to be zeros. So it's going to be 9, 9, 9, 9. It's going to be 1, 1, 1. Here we go. 1, 1, 1, 0, 0, 0. So I'm going to come here, come here, come here, and then I am going to come here. I'm going to say that so And M is this one right here, number of elements. So I guess I'm just gonna go towards the end. Okay. So if what? If nums of 1 pointer 1 is larger than is smaller than nums 2 of pointer 2, then I want to scooch everything over, right? Yeah, I think so. Then I want to, for index in range, starting at what? Where am I starting? So I'm going to try to take this value and I want to move this value and everything else 1 over. Okay. So range of starting at my current index, which is going to be pointer 1, start and stop, non-inclusive, is going to be M. Okay. What do I want to do? Actually, I think I want to go. I want to start from the back, right? That makes sense to me. Is I want to start from the back, so that way I'm kind of preserving things as I'm moving them over. Because if I start from the front, I'm going to copy the first element, but I'm going to kind of replace the second element that I'm now need to move to the third. So I don't want to start at the beginning. I want to start from the back. So how am I going to do this? I want to start at M. I want to end at pointer 1. And I want to have a step of -1. I think that's the... Is there a thing to tell me? No, it doesn't look like there's a thing to tell me. That's okay. We can... Now, start is inclusive, and I don't actually want to do that, right? I am -1, pointer +1. So again, I'm definitely noticing that I have a lot of problems with these off by 1 kind of like things, trying to think through this. It's definitely something I need to try to improve upon. I'm not sure. I'm just gonna go with it right now. So what do I want to do? I want to take index and move it over by 1. So nums of 1 at index plus 1 is equal to nums 1 at index. So I'm taking the value before it and putting it in my current one. And now that's why this index plus 1 is going to be, I don't want to get the last element because I don't want to do the last element plus 1. And I do want to include the current element, and the end is non-inclusive, I think. So like that. Okay. Then I want to insert the number from nums2 into the current position at nums1 because I just made room for it. So nums1 at pointer 1 is equal to nums2 at pointer 2. Okay. Then I want to increase pointer 2. Pointer 2 plus equals 1. Okay, so I keep doing that, and then I come to the end, and then I want to dump. If I come to the end, I need to now kind of, oh wait, no. I need to increase pointer. So else pointer 1 plus equals 1. Now is this equal to? If it's equal to, I can also do the operation. So let's do it like that. And then we just increase pointer 1. Okay, so at this end, once we're done with this, pointer 1 is at m. And then we just want to keep adding elements from pointer 2, all of the ones that we haven't done because they are still bigger, right? Those are elements are bigger. So while pointer 2 is less than n, okay, nums at 1 pointer 1 equals nums2 at pointer 2, and then we increase both pointer 1 and pointer 2. So pointer 1 plus equals 1, pointer 2 plus equals 2, and then we should be done. I don't know if this is gonna work. No, it doesn't like that. Out of the bounds of the array. Yeah. Yeah, I guess so. And pointer 2 is less than n. There. How about that? Oh, that's unfortunate. Alright, well. I definitely feel like this is a solution that I should be able to do. Like, I have the idea in my head of what I want to do. I can't execute upon it, which is highly, highly, highly concerning. Although I'm a little bit too tired to be even depressed or bothered by it. I'm kind of just like right now I'm tired. I'm tired. Every day I get off work and I'm just like, oh, I'm tired. I come home, I do Leetcode, and I'm just like, So I'm too tired to even be like, oh man, why can't I solve this? It's like, I didn't solve it. I'm gonna. I said that I was gonna go look at the answer, but looking at the answer only works when I have. Looking at the answer only works if I have the. How do I even want to say that? Looking at the answer only works if I don't have an idea of how to move forward, and I'm like, okay, I need help to do the problem. With this specific situation, I'm actually in a very different situation. If I'm gonna overuse the word situation, what's going on here is I have an idea of how to solve it. I'm just having weird issues. So I'm wondering, like, should I go to GPT, or should I try to come back tomorrow and do it? And although tomorrow I'm not going to be in a very fresh headspace either, because it's going to be the exact same problem. I just got off work, I'm tired. Okay. So, what do we want to do? Okay. So, I'm just going to I'm going to talk through it again and see if I can figure out this. So, I start at the beginning. Okay, 0, 0. Then I look which one's smaller. And my condition is when pointer 1 is less than m and pointer 2 is less than n. So if either one of those is false, then it will stop. Alright, so for pointer 2, what it's going to do is, if it's at the end, what does that represent? That means that we already put all of the elements in nums2 into nums1, so we should be good. And then this is not going to hit. And then we successfully did our insertions. Okay, so I think this is valid. How about this one? So, pointer 1 is less than m. So, m is going to be here. Okay. And I'm going to keep going until pointer 1 is here. And then, oh, but hold on a second. When I insert, I want to keep going. I want to add 1 to m, right? So when I insert, I want to do m plus equals 1, because now nums1 is shifted over by 1, right? So I don't want to stop here if all of a sudden I have elements that are here. Okay. Well, that was a valiant effort, but no. Okay, so then what do we do? So if nums2 is bigger, we need to put it. Okay, so if nums1, sorry, we look here. Oh no, I think if it's nums1 is greater, right? So if nums1 is greater, then we want to move everything over. Yeah, that should be it. Oh, plus equals 2, plus equals 1. But why does it say, what's this problem though? Cannot access local variable pointer 2 when it is not accessed with a value? Oh. I misspelled it. Well, let's just keep the misspelling. So, there. Now everything should be aligned. Okay. I'm... Okay, so I misspelled both of them. But I did it consistently. That's actually kind of funny, isn't it? Okay, let's see if it works. Wrong answer. So I should have looked at this one and then moved everything over by one, right? Start. Or is this -1, right? Because I do want to move over this pointer value, but I'm doing the opposite. So I was doing +1, and then I should have done -1 because like the stop is non-inclusive, and so when you stop, it's non-inclusive. Now when you're counting from 0 to m, if you want to include this value, it would be m+1. But because I'm counting from from something to m, and I want to include this, but I'm counting down, it's not +1, it's -1. So that accepted. Hey! Nice. Although I am noticing, so my solution is here, and here is what I'm guessing is kind of the optimal solution. So I solved the problem, but I didn't do it optimally. So let's go to Copilot and ask it about it. Here is my solution. Can you show me any better solutions to... which problem are we doing? Merge sorted array. All right. Okay. Absolutely. Your solution is on the path and can be improved. Oh, it's almost 10 o'clock. Hold on a second. I'm going to just make sure that Blue Origin is not launching right now. So I don't know if it is... Okay, cool. They're still not launching. I think it's in one more hour. It's okay. I just wanted to make sure that Blue Origin is not launching their rocket because I wanted to watch that. So, anyways, if it was, I was gonna be like, okay, bye guys, I'm gonna go watch that rocket launch. But we still have an hour, so we can look and investigate this. Okay, so merge. Do not return any. Okay, sure. Okay, is to use 3 pointers and merge the arrays to form... Okay, so we're using 3 pointers. We're doing pointer 1 is m-1, then pointer 2 is n-1. So m is the length of nums 1. N is the length of nums 2. And then end is the end of like the total number of elements. Right, like that's what pointer 1 will be, m plus n. And then -1 is for the indexing. Or because it's an index, not a number, right? Okay. So, what do we do? Merge num1 and num2 from the end to the beginning. Okay, so well, pointer 1 is greater than 0, so while we're not at the end, and pointer 2 is not at the end, okay, that's very similar to what I did here. I check if nums1 is larger than nums2. If so, nums1 at the end equals nums1 else nums1 at the end equals how's that working? Okay, I know that they're doing some kind of musical chairs with the elements in the array. I think I need to stop being lazy. I need to walk through it. I don't want to walk through it. I don't want to do that. I'm honestly, I'm just being lazy right now. I need to do it. I just don't want to. Okay. So nums1 is equal to 1, 3, 5, 7, 7, 9, 0, 0, 0, 0. Okay. nums2 is equal to 3, 4, 10. 1, 2, 3, 4, and 11. Okay. So now we're at this end, and we're at this end, and we're at this end. Okay. I come here, and I check if nums1 is greater than pointer nums1 at pointer 1. So that's right here. Is greater than nums2 at pointer 2. So that's 11. And in this case, that's not true because 9 is not greater than 11. So we come to this else. nums1 at end here is equal to end, this one right here, is equal to nums2 at its respective thing. So we just go 11. Okay. Then pointer 2 minus 1. So now we're looking at this. Then we go and say we're no longer looking at this end, we're looking at this. Oh, I kind of see how this is working. Then we come here and we go nums1 at pointer 1, which is right here. Is it greater than this one? No, it's not. So what do? We once again add 10 here. Then we decrease pointer 1, so now we're looking here. And we decrease our end, so we're looking here. Okay. Then what do? we come back up here. Nums1 is nums1 greater than nums2, which is 4. Yes, it is. Okay, cool. So now what do? Well, we take, okay, so nums1 end, which is here, equals nums1 that I'm looking at. So it's 9. Okay? And then okay, then I decrease here. Okay. And then I decrease here. Okay, so now I'm looking here. And then I do the same thing. So I look at this 3. Then I look at this 7. And then I put 7 here. 7 here. But then that's a little bit cattywampus. I might have messed something up in my logic, but it's doing musical chairs with the different elements like that. So cool. Nice. All right, well, we accomplished our goal today, which was to see a sorting problem, to kind of put it in our heads. Again, as I said at the beginning of this video, it's not going to be intense. I'm not going to be like, I will 100% understand it. I will commit it to memory. Nah. Right now, we're just relaxing a little bit. We're continuing to do Leetcode. We're continuing to move forward, but not at a high intensity. So we accomplished our goal. I was able to see this new problem. I was able to figure out a solution for myself. Not a very efficient solution, but I was able to figure out a solution. And then I was able to see, so that's the third point. I was able to see a more efficient solution. And number 4, I kind of understand. I get the idea a little bit of how the more efficient solution is working. Don't understand it fully, but that's okay. That's fine. So anyways, I'm satisfied with where I left off right here. I'm satisfied with it. So I think I'm going to end this video. I'm unsure if I'm going to make a project video today. Debating on it. It depends on how I'm feeling. Because I'm going to watch that rocket launch. I think it's at 11 o'clock, actually. It's Jeff Bezos's Blue Origin. Their brand new rocket. So New Glenn is what it's called. And it's the first launch that this rocket has ever attempted. And so I'm super excited for it. I hope everything goes really well, everything works out. I'm going to be watching it and just so happy to see it go. So I'm going to end this video, go and watch that, and then if I feel up to it, I'll make another video, but to be completely honest, it's probably going to be like midnight, and I'm just going to be like, I'll do a project tomorrow. I'll do my project videos tomorrow. Alright, so anyways, thank you guys so much for watching this video. I hope you enjoyed it. And I hope that you guys have a absolutely wonderful rest of the day. My name is Timothy Lee Grant, and I will see you